we will work out some problems on empirical formula and molecular formula. A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine. Its molar mass is 98.96 gram. What is its empirical formula and molecular formula? To work out such kind of problems, you are supposed to prepare a table. In the first column, you are supposed to write the name of the element. Second column, you are supposed to write the percentage masses of this element. It has been given that a compound contains hydrogen, carbon and chlorine, and the mass percentage of hydrogen is 4.07, mass percentage of carbon is 24.27 and mass percentage of chlorine is 71.65. And in the third column, you are supposed to mention the atomic masses of those elements. We all know that atomic mass of hydrogen is 1 AMU, atomic mass of carbon is 12 AMU and atomic mass of chlorine is 35.5 AMU. And in the fourth column, you are supposed to divide the percentage mass by atomic mass. That is, column 2 is divided by column 3. The percentage mass of hydrogen is 4.07 divided by the atomic mass of hydrogen, that is 1, and that comes out to be 4.07, and percentage mass of carbon is 24.27, atomic mass of carbon is 12 and that comes out to be 2.02. Similarly, a percentage mass of chlorine is 71.65 and the atomic mass is 35.5 and that comes out to be 2.02 itself. In the fifth column, you are supposed to divide the value in column 4 by the minimum number in column 4. That is, column 4 has 3 values, 4.07, 2.02 and 2.02. Now, you are supposed to divide these numbers by the lowest number, and the lowest number can be taken as 2.02. That is 4.07 by 2.02, that comes out to be approximately 2. 2.02 by 2.02, that is equal to 1. 2.02, that will be equal to 1, and the simple ratio will be 2, 1, 1. That is, the simple ratio in which carbon, hydrogen and chlorine that is present in this given compound is 2:1:1. That is, the compound contains 2 atoms of hydrogen, 1 atom of carbon and 1 atom of chlorine. Based on this, we will write the empirical formula. Equal to CH2Cl. We know that the simple ratio is 2:1:1. That is, it contains 1 atom of carbon, 2 atoms of hydrogen and 1 atom of chlorine. Now, we will calculate the empirical mass. empirical mass will be equal to 1 into atomic mass of carbon, that is 1 into 12, plus 2 into atomic mass of hydrogen, that is 2 into 1, plus 1 into atomic mass of chlorine, that is 35.5. That comes out to be 12 plus 2 plus 49.5. Now we are supposed to calculate the value of N. We all know that N is equal to molecular mass by empirical mass, and molecular mass is given, that is 98.96 gram, and the empirical mass is calculated, it is 49.5 grams, and the value of N will be approximately equal to 2. We all know that molecular formula is equal to empirical formula into N. Empirical formula is CH2Cl into 2, and the molecular formula of the compound will be C2H4Cl2. A compound contains 2.22% hydrogen, 26.66% carbon, and rest oxygen. The molecular mass of the compound is 19. Find out its empirical formula and molecular formula. Here it is given that the compound contains hydrogen, carbon, and oxygen, and the percentage composition of hydrogen is 2.22, percentage composition of carbon is 26.66, and oxygen will be 71.12%. We all know that atomic mass of hydrogen is 1, carbon is 12, and oxygen is 16. And in the fourth carbon, you are supposed to divide the percentage mass by atomic mass, that is 2.22 divided by 1, that will be equal to 2.22. Next thing, 26.66 divided by 12, that will be equal to again 2.22, and 71.12 divided by 16, that will be equal to 4.44. In the fifth column, you are supposed to divide the values in column 4 by the minimum number in column 4. The minimum number in column 4 is 2.22 itself. Therefore, 2.22 by 2.22, that will be equal to 1. 2.22, that is equal to 1. That will be equal to 2, and the simple ratio will be 1, 1 and 2. That is, this compound contains 1 atom of hydrogen, 1 atom of carbon, and 2 atoms of oxygen. Based on this, we will calculate the empirical formula and the molecular formula. the empirical formula of the compound will be equal to Ch(O2) and the empirical mass will be equal to 1 into atomic mass of carbon, that is 1 into 12 plus 1 into atomic mass of hydrogen, that is 1 into 1 plus 2 into atomic mass of oxygen, that is 16, that is 12 plus 1 plus 16, that comes out to be 39 gram, and it has been given that the empirical formula of the compound will be Ch(O2) and the empirical mass will be equal to 1 into atomic mass of carbon, that is 1 into 12 plus 1 into atomic mass of hydrogen, that is 1 into 1 plus 2 into atomic mass of oxygen, that is 2 into 16, and the empirical mass is found to be 45 grams. Now we are supposed to calculate the value of N. We all know that N is calculated by using the formula molecular mass by empirical mass. The molecular mass of the compound is already mentioned, that is given as 90 gram, and the empirical mass is found to be 45. Therefore, the value of N will be equal to 2, and the molecular formula is calculated by using the formula molecular formula is equal to empirical formula into N. The empirical formula, as we all know, that is Ch(O2) into N, and the molecular formula will be equal to C2H2O4. Stoichiometry and stoichiometric calculations. Stoichiometry is derived from two Greek words, stoichion, which means element, and metron, which means measurement. Therefore, stoichiometry deals with the masses of the reactants and the masses of the products. In simple, to understand stoichiometry, we will consider a simple equation where methane undergoes combustion in the presence of oxygen to give carbon dioxide and water. Here the coefficients 2 for oxygen and water are known as stoichiometric coefficients, and the stoichiometric coefficients for methane is 1 and the stoichiometric coefficient for carbon dioxide is also 1. According to this equation, 1 mole or 1 molecule of methane combines with 2 moles or 2 molecules of oxygen to give 1 mole or 1 molecule of carbon dioxide and 2 moles or 2 molecules of water. That is, you have 1 mole of methane reacting with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 moles of water, or in other words we can put it in this way, 16 gram, which is the molecular mass of methane, will combine with 2 into 32, that is 64 grams of oxygen to produce 44 grams of carbon dioxide, and 2 into 18, 18 is the molecular mass of water, 2 into 18, that is 36 gram of water. That is, for complete combustion of 16 grams of methane, you require 64 grams of oxygen. And when 16 grams of methane combined with 64 grams of oxygen, it produces 44 grams of carbon dioxide and 36 grams of water. Or we can also put it in this way, 1 mole of methane, we all know that 1 mole of any gas at STP occupy a volume of 22.4 liters. Therefore, 22.4 liter of methane combines with, you have 2 moles of oxygen. If 1 mole occupy a volume of 22.4 liters, then 2 moles occupy a volume of 44.8 liters. 22.4 liters of methane combined with 44.8 liters of oxygen to produce 22.4 liter of carbon dioxide and 44.8 liters of water. Calculate the mass of iron which will be converted into its oxide, that is Fe3O4, by the action of 18 gram of steam on it. The balanced chemical equation for this reaction is 3Fe plus 4H2O gives Fe3O4 plus 4H2. Now, according to this equation, 3 into 56, where 56 is the atomic mass of iron, therefore 3 into 56, that is 168 gram of iron combined with 4 into 18 is the molecular mass of water, that will be equal to 72 gram of steam. That is 72 gram of steam combined with 168 gram of iron. Now, you are supposed to calculate the mass of iron that will be converted into its oxide by the action of 18 gram of steam. Now, 72 gram of steam is required to convert 168 gram of iron into its oxide. Therefore, 18 gram of steam will convert what mass of iron into its oxide, that is 72 gram of steam will convert 168 gram of iron. Now, 18 gram of steam, 18 gram of steam will react with 168 into 18 by 72, that will be equal to 42 gram of iron. Reactions in solution. We all know that in laboratories majority of the reactions takes place in solution. Therefore, it is really important to express the concentrations of the solution or the amount of substance that is present in a given volume of the solution. The concentration of the solution are expressed in different ways. Now, we will consider the different ways in which we will express the concentration of the solution. Mass percentage or weight percentage. It is defined as the amount of solute in gram dissolved in 100 gram of the solution, and it is given by mass percentage is equal to mass of the solute by mass of the solution into 100. We know that solution is a homogeneous mixture of solute and solvent. Therefore, mass of the solution can be taken as mass of solute plus mass of solvent. Therefore, mass percent is equal to mass of solute into 100 by mass of solute plus mass of solvent. For example, if I want to prepare 10% sugar solution, then I need to dissolve 10 gram of sugar in 90 gram of water so that the total mass of the solution will be 100 gram, and that represents 10% sugar solution. That is 10 gram of sugar in 90 gram of water or 10 gram of sugar in 100 gram of the solution. A solution is prepared by adding 2 gram of a substance A to 18 gram of water. Calculate the mass percentage of this solute. Now, it has been given that 2 gram of a substance is added to 18 gram of water. Here, the substance A becomes the solute and mass of the solute is 2 grams and water is the solvent and mass of water is given, it is 18 grams. Now, we are supposed to calculate the mass percentage of the solute. We all know that mass percentage of any substance is given by mass of that substance into 100 by mass of the solute plus mass of the solvent. It has been clearly mentioned that mass of the solute, that is A, is 2 and mass of the solvent is 18 gram. Therefore, mass percentage of A will be equal to 2 by 2 plus 18 into 100, that is equal to 2 by 20 into 100, and that comes out to be 10%. Mole fraction. Mole fraction is defined as the ratio of number of moles of a particular component to the total number of moles of all the components present in a solution. To understand mole fraction, now we will consider a binary mixture. A binary mixture is one which consists of two components, and let us indicate the two components as component A and component B. Now, let us assume that the solution contains Na moles of component A and Nb moles of component B. Now, mole fraction of component A, which is denoted by Xa, is given by number of moles of component A by the total number of moles of all the components, that is number of moles of component A plus number of moles of component B. According to the definition, it is the number of moles of that particular component to the total number of moles of all the component in the solution. Similarly, mole fraction of component B will be equal to number of moles of component B divided by total number of moles of all the components, that is number of moles of component A plus number of moles of component B. Molarity. Molarity is defined as the number of moles of solute dissolved in 1 liter of the solution. That is, molarity M is equal to number of moles of solute by volume of the solution in liter. We all know that number of moles is given by mass by molecular mass, and therefore molarity can be written as mass by molecular mass into 1000 by volume. Calculate the molarity of NaOH prepared by dissolving 4 gram of it in 250 ml of the solution. We all know that molarity is given by the formula mass by molecular mass into 1000 divided by volume. They have given that mass of NaOH is 4 gram and it is dissolved in 250 ml of the solution. Mass is given, volume is mentioned, and we all know that the molecular mass of NaOH is 40 gram per mole. We will substitute in this equation mass, which is 4 gram, molecular mass of NaOH, which is 40, into 1000 by volume, which is mentioned, that is 250 ml, and it comes out to be 0.4 mole per liter or 0.4 molar. Molality. Molality is defined as the number of moles of solute dissolved in 1 kg of solvent. That is, molality is equal to number of moles of solute by mass of the solvent in kg. We all know that number of moles is given by mass by molecular mass. Therefore, molality can also be written as mass by molecular mass into 1000 by mass of the solvent. Remember, molality of a solution is independent of temperature. That is, molality does not depend on temperature, whereas molarity is dependent on temperature. Molality is temperature independent, whereas molarity is temperature dependent. Calculate the molality of NaOH prepared by dissolving 4 gram of it in 250 gram of water. We all know that the formula to calculate molality is mass by molecular mass into 1000 divided by mass of the solvent. Mass of NaOH is given, mass of the solvent is given, and we know the molar mass of NaOH. Substituting in this formula mass, which is 4 grams of NaOH, by molecular mass of NaOH, which is 40, into 1000 by mass of the solvent, which is 250 grams. Substituting in this equation, the molality is found to be 0.4 mole per kg, or it is 0.4 molar.